everyone, welcome back to my channel. So this is about average values for half-wave rectifier and its output voltage we will find in this video. So just consider let V is equal to Vm sine omega t, okay, or you can take it as Vm sine theta. This be an instantaneous sinusoidal voltage, okay. Now if you can consider if VDC is average or DC value of the output voltage, okay, across RL, the load resistor we are taking, right? So then the VDC value can be given as VDC is equal to area under the curve of full cycle divided by its base. This is the VDC value. Okay, that means, for example, the graph is somewhere like this. Okay, so this is the input voltage. This is the sinusoidal input waveform you are giving. So for half-wave rectifier, so we will be having the output value will be only the upper part. I mean half wave will be there, right? So this remaining the below part, there will be no rectification done. Okay, so only the upper half cycles will be done. Okay, so the area under the curve of the cycle, okay, on the cycle divided by the base. So this is 0, pi, 2 pi, the values will be in this way. So if you take the complete cycle, it is 0 to pi. One sinusoidal wave will be 0 to pi and the voltage will be V here. Okay, so considering this, we can write it as, if you take the, here the conduction is taking place from 0 to pi. So we will take it as 0 to pi. Voltage will be V here. That's all right. So V d theta, okay, divided by complete whole cycle is 2 pi. The base is complete 2 pi divided by 2 pi. Oh, sorry, we should write like this: 0 to pi V d theta divided by 2 pi, whole pi. Okay, this is VDC. Okay, so that is nothing but you can write it as 0 to pi. V value we have considered here as Vm sine theta. So just substituting that over here, Vm sine theta d theta by 2 pi. Taking this 2 pi the other side, that will be 1 by 2 pi integration 0 to pi Vm sine theta d theta. So this will be Vm taking outside, Vm by 2 pi, integration of sine is minus cos theta 0 to pi. Okay, so this is Vm by 2 pi minus cos pi minus of minus cos 0. Okay, so this value will be this cos pi. So this value is 1 minus of minus 1. Okay, so minus of minus 1 will be 1 and this cos 0 is 1 minus of minus 1. Okay, so Vm by 2 pi. So this will be 2. 1 plus 1 will be 2. So I'll just write here. Okay, so 2 Vm by 2 pi. Okay, 2 Vm by 2 pi. This cancel. The answer is Vm by pi. If you take 1 by pi Vm, 1 by pi value will be 0.318 Vm. So this is VDC. Okay, I hope this is clear. Now we will see RMS of load current. Okay, very simplifiedly I am telling this. IRMS is equal to square root of integration 0 to 2 pi I square d theta by 2 pi. So this will be 1 by 2 pi square root of integration 0 to 2 pi Im square sine square theta d theta. Here I means nothing but Im sine theta. That is what I am substituting over here. Okay, after this, so we can differentiate this, I mean partial differentiate this. Like for example, if there is suppose something a to b d theta, then you can write it as a to c d theta plus c to b d theta. Okay, you can do in that way also. Okay, in similar way again you can split this. Okay, so square root of 1 by 2 pi integration 0 to pi im square sine square theta d theta plus pi to 2 pi. Pi to 2 pi, the if you see in the graph, that value is 0. Okay, so d theta, I'm directly writing 0. So this whole value will be 0. So we are only doing for this one. Okay, square root of 1 by 2 pi. So here sine square theta can also be written as pi to 0. I'll just show you. Im square into 1 minus cos 2 theta. Sine square theta can be written as 1 minus cos 2 theta d theta. Taking im square outside, you can write it as im square by 2 pi integration 0 to pi 1 minus cos 2 theta d theta. Integration of 1 will be theta. Integration of cos 2 theta will be sin 2 theta by 2. Okay, just writing that im square by 2 pi. Alright, here it will be, this will be 1 minus cos 2 theta by 2. Sin square theta will be 1 minus cos 2 theta by 2. Okay, this is the formula. Just write one more time. Sin square theta is equal to 1 minus cos 2 theta by 2. This is the formula. Okay, we are substituting that over here. So this 2 also, if it go here, it will become 4. Integration 0 to pi 1 minus cos 2 theta d theta. Again writing this im square by 4 pi. This theta minus sin 2 theta by 2, 0 to pi. So this value will be, I'll write little smaller, im square by 4 pi. So this will be pi minus sin 2 pi by 2. Sin 2 pi by a value will be pi minus 0. So this will be square root of im square by 4 pi into pi minus 0 will be pi. Pi cancel. Square root of im square by 4 will be im by 2. Okay, we'll just write over here RMS is equal to im by 2 or 0.5 im. RMS. Okay, this we got. Alright. IAC we got it as im by pi, the previous one, right? Remember this too. Next part is ripple factor. It is a ratio of RMS of AC component of load current and to average value of load current. The first I average and this is I RMS. Okay, this both derivations we have done, right? We will see here. It is denoted by the letter gamma. Okay, IAC by IDC. Simply if you write, you can write like this. Okay, so RMS of current just now we have derived, right? It is also given by I RMS is equal to square root of I square DC plus I square AC. I square AC. Alright, from this IAC can be written as square root of I RMS square minus I square DC. Simply this is going this side and this is coming inside, that's why minus. Okay, so this is IAC value. Substituting this in the ripple factor IAC by IDC. So IAC we got here I square RMS minus I square DC divided by IDC. Okay, dividing this IDC here with both the terms. So that will be I square RMS by IDC. Okay, IDC whole square minus 1. We can simplify, right? And write like this, no? IRMS by IDC square minus 1 will be again IDC square by IDC. You can write like this. Okay, so this value IRMS value we got it as IM by 2 whole square. Complete whole square. IDC is IM by pi whole square minus 1. So this will be, if you cancel IM and this will be, if you go to the numerator, it will be pi square by 4 minus 1. So the value will be 1.57 square minus 1, that is around, sorry, is equal to, if you take square root and solve everything, 1.21. So the ripple factor gamma is 1.21. Okay, so see, if the ripple factor is greater than 1, the RMS value of AC component is greater than the DC. AC is greater than DC then. Okay, if ripple factor is less than 1, then AC is lesser than DC. Okay, clear? This is how a ripple factor is done for half wave rectifiers. I hope this is clear. If you have any doubts, please let me know in the comment section. I think this is useful. Please check back this video, and I just want to make an important note over here. In the previous video of RMS of load current, I have derived this whole, but I forgot to keep this square root for the whole term. In the end, I kept square root somewhere over here, but you should keep completely for the whole term, or 1/2 for the whole term. Then only you will get this expression here, square root of Im squared by 4. That will be Im by 2. Okay, just remember this. Just telling once again. Thank you.